Hello, dear students. I am Samir Velankar. I welcome all of you to this third video on infix, prefix, and postfix expression evaluation. In this video, we will see how to evaluate a postfix expression. We know that postfix expressions, as far as evaluation is concerned, are very efficient as compared to infix. They are faster to evaluate as compared to infix. But what is method or algorithm for evaluation of postfix? This we will see in this video. So I have kept myself ready with the algorithm and some writing work also. Let's see what we are supposed to find out. In the comment section of the algorithm, I have described that let P be the given postfix expression. Well, this is the postfix expression that we want to evaluate. Let P be the postfix. So let us assume that P is ABC star plus as written. ABC star plus. We want to evaluate this. And now in the algorithm, we are going to use a stack. So that's the application I was talking about. Stacks will be used for evaluating postfix expression. So let that stack be S. And the stack is empty initially. So you can say that top of stack is -1. Now this stack is going to store operands of the postfix expression. You will know that as we proceed reading the algorithm. So it is stack of operands. We are not going to store operators in the stack like multiplication or division or addition. Also, in this algorithm, we are going to use a function next token. We assume that this function is available. We are not defining this function. Next token function will return the next symbol from the postfix expression. So let's see what is the algorithm. Let's see. Here we have defined an algorithm called evaluate postfix, and the parameter passed is the postfix expression. Now in our case, the postfix expression we are assuming is ABC star plus. This is the postfix given as the parameter to evaluate postfix. Now what is the method is the postfix expression given ABC star plus is scanned by our algorithm from left to right. It is scanned from left to right. While scanning, what we do is we take individual token, check the word, individual one single token from the postfix. Like tokens here are A, the next token is B, then next is C, then there is a token asterisk, that is multiplication, and finally there is token plus. So every time, when we try to scan the expression, we get the next token, and that is given by the function called next token of P. P is the postfix. Okay, when the algorithm starts here, the entire algorithm is controlled by the while loop. So when this while will end, the algorithm will end. And the while boolean expression is while expression P is not finished. Look at this. We can write such conditions in the algorithm. It's as if it's like English. We are writing some English para, and we have written the condition as while expression P is not finished means we are scanning the postfix, isn't it? From left to right. And while scanning, we will come to end of it someday or the other. When we come to end of postfix, when we go past the last token, that is plus, when we will go past it, this while loop will stop. So while expression P is not finished, continue. Okay, so let's start the while loop. First line written is let x is equal to next token of P. So first time the next token of P is going to be the first token. So x, which is equal to next token of P, first time is going to be A. That is the first token of ABC star plus. So X loads the very first token, which is A. Now there are only two possibilities. Everybody know this. There are only two possibilities. The token that we have got, that is whatever token we have got in X, can be either an operand or an operator. Postfix expression P will have either an operand or an operator. It does not have brackets. Hello. I hope you have come from the first video, you have watched it. Infix expression may contain brackets. Postfix expression do not contain brackets. But postfix contains only two things, either an operand or an operator. So after taking out a token, x is equal to next token of P. X can be either an operand or an operator. So we will simply check if X is operand. Note how English like is this condition and is allowed to write in the algorithm. So let's ask, is X an operand? Yes, it is, because X is small a. It is an operand. If we discover that X is operand, then we will simply push X on the stack S. So the S stack, which was initially empty, will now have a, we have pushed it on the stack. All right. And the else will not run, isn't it? Because the if was true, else will not run. So if else doesn't run, this entire part of else is skipped and we go back to while, isn't it? We'll be back in the while loop. I hope you are understanding structure of this while. So if we go back to the while, we are going to pick up the next token. So the summary of this while loop is take out the next token and check whether it is operand. If it is not an operand, then go to else because it is surely an operator. So let's go back to while. And expression P is not yet finished. There are many tokens left. So we again take out the next token and load it in X. Now X is equal to next token of P is going to give us B. B is the next token after A, isn't it? And now we inspect what is this X. It can be either operand or an operator. When we ask is X an operand, yes, it is an operand. It is B. So we will push that X on the stack. So B joins on top of A on the stack. Yes, everyone. And else is again dropped. And if else is dropped, we will go back to while. As else is dropped, we will be back in the while, isn't it? So let's go back to while. In the while loop, we check again, is expression P not finished? Yeah, it is not finished. Lot of tokens still pending. So we again take out the next token. The next token of P this time is going to be C. After A and B, C is the next token. And check that it is also an operand. So I will push C on the stack. And else will be dropped. And we are back to while. Now starts the fun part, interesting part. Just keep an eye here. After C, the next token, that is X, that we are going to get is asterisk symbol, isn't it? That is operator we are going to get. Next token is asterisk. So X is asterisk. Then we ask, is X an operand? No way. X is an operator. So we will land in else. Now this else will run. Whenever we get an operator, we do exactly opposite. We execute two pop operations back to back. So the first pop, if we execute pop first time, we are going to get C out of stack. And the second pop, we are going to get B out of stack. And C and B will be lost from the stack because we have popped them. If we say that op1, just a variable, op1 is a variable like xyz, I have named the variable as op1. If we say op1 is result of first pop, then op1 will be C And if I say OP2, just a variable again, is equal to result of second pop, then OP2 is going to be. So we have got two operands out of the stack, and we have loaded the two operands in the variables OP1 and OP2. Now what? Now we should multiply these two operands, isn't it? Yes, we should multiply because the operator that we got, no, the operator that we got in the variable x was asterisk. So we should multiply OP1 and OP2. But be careful, multiply will be done in such a way that OP2 will be on the left hand side and OP1 will be on the right hand side. Don't argue. Don't say what difference it makes if you say OP1 into OP2 because multiplication is commutative. I agree. But the operator could have been division, operator could have been subtraction. So we will take this care of writing OP2 always on the left of the operator and OP1 on the right of the operator, isn't it? And you really see that this is B into C. OP2 is B and OP1 is C. And we will load this answer in R. One more variable we will take. R will become B into C. So we have got C out of stack. We have got B out of stack. We calculated R. R is B into C. And now what to do with R? Yes, I'm sure you know this. This R should be again pushed on the stack. I hope you are understanding. So R once pushed on the stack, then R is nothing but the result of B into C. Partial expression has been solved. So let's see else. In the else, we are saying OP1 is equal to pop S. You know, in the current situation, OP1 will be C. Next is OP2 is equal to pop S. In the current situation, OP2 will be B. Now we apply the operator X on OP2, note on OP2 and OP1. So OP2 will be on the left of the operator. But really this X is an operator, agreed X is an operator, then but we should check it, isn't it? Which operator it is. Accordingly, we will apply the operation. So the if checks if X is multiply, then do multiplication and store the result in R. Else if X is division, then do division of OP2 and OP1 and store the result in R and so on, plus and minus. And after this, we will push R. This is so important. We will push R on the stack S. So the result is pushed on the stack. So what do you now see? You don't see C in the stack. You don't see B in the stack. Both were multiplied. R was the result and R was pushed on the stack. Okay, nice. Now what? Now what next? After pushing R on the stack, check the next line is end of while. So we will go back to while. And if we go back to while, we are going to take out the next operand, isn't it? Next token. So what's the next token? Next token after multiply, as you see, is plus. And we are going to again ask, is it an operand? Is it an operand? No. So we are going to land in else. And in else, we will first take out OP1 as pop S. So R will be taken out first. So OP1 will be R. Yes, everyone? OP1, first operand taken out will be R. And second pop is going to give us A. So OP2 is going to be A. Now what do you do with this OP1 and OP2? You apply the operator. The operator was plus. You apply this operator. But you will apply it in such a way that OP2 will be on the left of plus and OP1 will be on the right. Store it in the result R. And once R is evaluated, push R on the stack. So that's what has been done in the remaining code. Here addition is true, so we will add OP2 and OP1 and push the result in R. So now what do you see on the stack? R and A were popped, so they are lost, but they were added. R was computed and R is pushed on the stack. I hope you're understanding. Now when we go back to while will say enough. While is going to break now, isn't it? Why really? Because the expression P is over. Check that plus was the last token. So while is stopped. And when we come out of the while, we are sure about one thing. Tell me, you are sure about one thing, that stack contains only one value. Yes, everyone. See this stack. S. The stack is containing only one answer. That is the final result. This is R is the final result of our expression. So after the while loop, it is a good idea to execute one more pop. So final result is equal to pop S. So if we execute pop, final result will be R, and we return this final result back from where this function or algorithm was called. So as easy as it is, isn't it? This is how the postfix is evaluated. Have you observed one thing again? That to evaluate the postfix expression, we had scanned the expression from left to right only once, isn't it? Okay, before we end this video, let's see let's see some example again. Where in a very quick manner, we will see an example. Suppose we had an infix like this. Infix was a plus b upon c minus d into e. Okay. Then what is the postfix of this? This is ab plus upon cd minus into e, and then upon will be done first. So ab plus cd minus slash into e, and finally ab plus cd minus slash e asterisk. Okay. So this is the postfix. And suppose we are now asked to evaluate this postfix. We will use our algorithm. Okay. Do you imagine some values for a and b? Imagine a is 5, b is 2, then plus. Then let's say c is 10, d is 2, minus, then slash, and e is 3 and multiply. All right. So these are the values that we are having. Now, how is our algorithm going to perform? This is the stack S. When we scan this postfix from left to right, we get a token phi. Notice, first token is phi, and phi is an operand, so push it. Then next token we get is 2. 2 is an operand, push it. Next token we get is plus, but plus is an operator. So you pop 2 and phi. So you notice OP1 will be 2 and OP2 will be phi. And the operator you got was plus, so you will perform 5 plus 2. Note OP2 on the left, OP1 on the right, and you will get the result as 7. What will you do with this 7 is you will push it on the stack, isn't it? So now the stack does not have 2 and 5, but the stack has 7. So this portion, phi 2 plus, has already got evaluated as 7. So you notice on the stack we are having 7. Now when you continue scanning the postfix expression, the next token you get is 10. It was 10 2 minus, isn't it? So the next token you get is 10. 10 is an operand, so you push it. Next token you get is 2. 2 is an operand, so push it. And now the next token you get is minus. Minus is an operator. As minus is an operator, you will execute two pop operations. 2 and 10 are popped out of the stack. So OP1 will be result of first pop, and OP2 will be result of second pop. So OP1 is going to get a value 2. It was the result of first pop, and OP2 is going to be 10. It is the result of second pop. Now you will apply minus. Yes, minus was the operator, but it should be 10 minus 2. Notice OP2 on the left and OP1 on the right of minus, and the result you will get is 8. This is R, the result, and you will be pushing this result on the stack. 2 and 10 are already popped out. 7 is still lying down in the stack, and what are you going to get is 8 on top of 7. Now when you continue scanning the expression, by the way, 10 and 2 and minus have got operated. This is now 8. And remember, what you already had was 7. Got it, everyone? I hope so. Now, if you keep scanning the expression, you will get division. Now, division is an operator. So, what you would do is you will pop 8 and 7. If you pop 8 and 7, OP1 will be 8, result of first pop, and OP2 will be 7, result of second pop. Now you have to apply division operator because division was the operation we got. So it should be 7 upon 8, isn't it? 7 upon 8. OP2 upon OP1. So 7 upon 8 will be what? 0. 8, 64. Yes. 8, 0.8 something, isn't it? 0.8, let's say. So the stack is going to get, this is the result, isn't it? 0.8. And you push the result on the stack. So stack is going to now load 0.8. So 7 upon 8, notice this 7 upon 8 has been done. And 7 upon 8 is nothing but something like 0.8. And now when you scan the expression, we get the next token as 3. 3 is an operand, so we will push it. And finally we get multiply. Multiply is an operator. Multiply is an operator, so we will pop the stack 2 times. And we are going to get 3 out of stack first. And we are going to get 0.8 from the stack second. And now we will apply multiply. Multiply will be 0.8 into 3, OP2 on the left again, OP1 on the right. And this is going to be something like 2.4. And this is the result, 2.4, which will be pushed on the stack. So stack will now contain only one value, one answer, that is 2.4. And this is our final. I hope you have understood every aspect of this algorithm, how to evaluate postfix expression. Thank you very much.